E4 JavaScript framework in Eclipse. Here you can see E4 JavaScript framework. The past few years has been a blurring of distinction between browser-based applications and traditional desktop applications. Browsers and widgets and the language frameworks within them are beginning to approach the sophistication of desktop operating systems. At the same time, desktop applications are becoming more web-enabled and are adopting some of the user interaction and stylistic trademarks of web applications. While there will be demand for both traditional desktop and browser applications for some time, there is increasing demand for software components to be able to live in both of these worlds. In component-oriented software such as Eclipse, we no longer select the target platform and then build a monolithic software stack on top. We begin with a large collection of available components and then stitch them together to build an application that suits our requirements. If we can reuse the same components in multiple runtime environments, it greatly reduces development and maintenance costs. E4 is exploring component reuse across multiple target platforms and technologies in a number of ways. One such area is writing Eclipse component in JavaScript. As the de facto standard language for client-side browser programming, JavaScript is a good choice for anyone seeking to write components that will run in a broad set of runtime environments. To that end, E4 is investigating bringing both the benefits of Eclipse to the JavaScript world, modularity, extensibility, and tooling, and JavaScript components into the Eclipse desktop environment. While the current E4 focus is on JavaScript, the intent of this work more generally is to make it easier to write Eclipse components in a variety of different languages. While JavaScript has long been used as a browser scripting language, it has rarely been used to build large-scale applications like we see in the Java world. One weakness in this area is lack of good modularity mechanism. There is no mechanism for defining and accessing namespaces, for expressing the dependencies of segments of JavaScript code, or for querying and consuming services defined in other components in an extensible way. In Java and Eclipse, we have the powerful and mature OSGI modularity system, among others, that satisfy these requirements. To address this limitation, E4 includes a modularity framework based on OSGI for use in JavaScript applications. As well as integration of JavaScript bundles in a traditional traditional Java-based OSGI runtime. This figure illustrates the architecture of E4 JavaScript framework and its relationship with pure JavaScript bundles as well as regular Java bundles. The E4 JavaScript framework is written in Java and runs as a pure OSGI bundle. It is responsible for parsing the manifest of JavaScript bundles and performing resolution of dependencies between JavaScript bundles. The OSGI framework has no knowledge of JavaScript bundles or their dependencies. The JavaScript framework essentially runs as a complete nested framework within an OSGI instance. Here you can see a JS bundle is inside JavaScript, and in Java side you can see these bundles and registration, extension registry, service registry, OSGI framework, Rhino and Java virtual machines are inside the Java section. Here bundles are connected to bundles, and this bundle is connected to plugged into a JS bundle, and here JS bundle is connected to bundle here, and bundle is connected to here service registry, and this bundle is connected to OSGI framework. Here extension registry is extension registry, service registry, and this bundle, and E4 JS framework are connected to OSGI framework here, and here JS bundle is connected to E4 JS framework. E4 JS framework is connected to OSGI framework and Rhino. OSGI framework and Rhino are connected to Java virtual machine here. And as an extra information, I can describe furthermore this architecture. The OSGI framework has no knowledge of JavaScript bundles or their dependencies. The JavaScript framework essentially runs as a complete nested framework within OSGI instance. Dependencies between JavaScript bundles and bundles can be expressed as at the bundle level as with the require bundle OSGI header, or at the level of individual script files similar to the import package OSGI header. These dependencies are expressed in JavaScript manifest written as JSON file. The JavaScript bundle can be defined and installed into the framework programmatically, and or the presence of JavaScript bundle can be declared in a regular OSGI bundle using an additional manifest header, JavaScript bundle colon script manifest.json. Although JavaScript and Java bundles can interact with each other by direct invocation, the recommended way to interact between two worlds is via the OSGI service registry or Eclipse extension registry. For example, the JavaScript bundle can also declare itself as a regular OSGI bundle and contribute a service to OSGI service registry, either programmatically or using declarative mechanisms such as OSGI DS. Regular OSGI bundle can then consume that service without ever knowing the implementation of that service is written in JavaScript. Similarly, the E4 JavaScript framework provides an Eclipse extension factory for instantiating Eclipse extensions written purely in JavaScript. A JavaScript bundle can simply declare a plugin.xml file with their contribution to the extension registry without writing a line of Java code. Bundles written in Java can then consume those extensions without knowing they are written in another language. Conversely, a JavaScript bundle can declare an extension point with some corresponding Java API that can be implemented by Java bundles, and then load and use extensions contributors to that extension point in JavaScript code. This type of interaction between JavaScript and Java bundles are illustrated in this figure. The E4 JavaScript framework itself defines API in both Java and JavaScript. Thus, pure Java bundles can query and manipulate the JavaScript framework. For example, install a new JavaScript bundle, and bundles written in JavaScript can interact with the framework through its JavaScript API. This is illustrated in this figure by the E4JS framework block extending across the Java and JavaScript boundary. The E4 programming model also facilitates integration of components written in other languages. With service-based interaction between components and dependency injection, components never need to know what language services are implemented in or what languages are being used to consume the services they expose. Similarly, the pared down Eclipse application services can be exposed as API stubs in other languages, so that the broad segment of Eclipse platform functionality can be quickly made available to other bundles written in other languages. A small JavaScript API for interacting with these core E4 services is currently available in the bundle org.eclipse.e4.ui.web. As a proof of concept, E4 includes a re-implementation of plugin development environment (PDE) update site editor written purely in JavaScript. This editor can be run in a web browser or seamlessly integrated into the Eclipse platform user interface. Now, this is the end of my presentation. Thank you very much for watching it.